Okay, I'm going to look at Pythagoras' theorem. Okay, now Pythagoras' theorem is often linked with the word trigonometry, but there is a difference between the two. Now, for Pythagoras' theorem, it must be, and the same as trigonometry actually, it must be a right-angled triangle. So if I drew a right-angled triangle on the board there, okay, what they found was, if you take the, let's call that the longest side, call that A, B, and C. Okay, what they found was that the longest side here, or what they call the longest side is equal to the hypotenuse. And that often comes up in your exam, so if they ask for an exam for finding the hypotenuse, then that is the longest side of a right-angled triangle. Okay, and what they found was, if you square the longer side, now the longer side is opposite the right angle because that's the bigger the angle, so therefore the gap's wider or further apart. So therefore they found that the longer side squared equals the other two shorter sides squared and added together. Okay? Now, when do we use Pythagoras? Well, when we've got a right angled triangle, but we could equally use that for trigonometry. So when we use Pythagoras is this: if you know two sides of a right-angled triangle and require the third, so you might know those two sides and require the letter C, or you might require these two sides. You might know these two sides and require that side, which is the longest side. So they could ask you for one of the two short sides or one of the longer sides. Now, in either case, if you know two sides and require the third, it's always Pythagoras' theorem. Okay, so that's the setup there with the diagram there. So let's go into some examples. So let's just take that off the board. Okay, now obviously I'm going to do this differently if you're a foundation or higher tier student. You decide to pick which method you prefer. So let's take a right angled triangle here. So I said it's got to be right angled, and let's say we'll call that 6 units, maybe 6 centimetres. And that one, let's have that one 7 centimetres. And we require the missing length there. We usually call them X. It could be any letters. There are 26 letters in the alphabet. If you're using a higher way of doing it, then you apply the theorem using the squared, which I said a few moments ago. So what you'd say is the longer side squared, which is always obviously the right angle, is always squared on its own. So it's X squared equals 6 squared plus 7 squared, the other two shorter sides squared and add together. If you work that out there, that gives you 36 plus 49. Adding those two together there gives you 85. What you then do at the end is you square root that. Now, strictly speaking, I'm being too technical here, square roots have a plus or minus answer, because when you square back, 2 positives make a positive, 2 negatives make a positive. Okay, and that would give you an answer of, well, it comes out on the calculator doing 9.21 ... So if we round that to one decimal place, because that's below 5, it's 9.2 centimetres to 1 dp. Okay. Now, don't take the negative value there. That's strictly correct, because if you did 9.2 squared, you'll get 85 near enough, because it's been rounded, so it's slightly out. If you did minus 9.2 all squared times it by itself, you would get, again, 85 roughly. Obviously it's not going to be the same because it's been rounded. But obviously you can't have a negative length, so you just take the positive value. So I'm not going to go into the details there too much. It's obviously the positive answer from that. Now, that's the way to do it if you were doing a higher student. If you were doing a foundation, you could do it that way, but better to teach it this way. I'm going to have a little bit of a rule which will go into my next example. So let's take foundation students. What I say to them, okay, they're trying to get those level 4s, 5s, 4 being a grade C. Okay, what you do is you square the sides. Okay, square the sides there. So 6 and 7 squared them together. But do you add or subtract? Well, rather than going through all that process of rearranging there, okay, what I say to students, you add if longest required. Otherwise, if it's not the longest side you're after, it's one of the two shorter sides, otherwise you subtract. Okay, you subtract from there. Just change those. Excuse me, mate, the pen's not working too well. So otherwise you subtract. So in the case of well, then obviously here you would then square root at the end to get your answer. So putting that in a nutshell there very quickly, simply, you want the longer side, which is the hypotenuse, so you square the numbers, add them together, which I've already told you comes out to be 85, and then all you do to get x is just take the square root of that, which I've done earlier, and that comes out to be 9.21, which if you round to 1 dp, 9.2 centimetres, and that's the rule I would use for foundation students. Okay, let's look at another example. Okay, just take those off. Okay, second example. Second example, let's look at a triangle. So let's look this time like that. Okay. Right, so you've got that there. So that's 10 units. It could be centimetres or millimetres, as long as they're the same units. It doesn't matter as long as they're. Now you can see it's Pythagoras theorem because you've got a right angle triangle, you've got two sides and want the third one. I'll call it x again. If I was using the higher way of doing it, what you would say is the longer side squared the hypotenuse is equal to the other two sides squared and added together the two short sides, x squared plus 3 squared. 10 squared is 100, 10 times 10, x squared, 3 squared, 3 times 3 is 9. Take 9 off both sides, that gives you 91 equals x squared. Okay, and then I'll just turn that because I work left to right. Take the positive square root of that, because obviously I've discussed earlier, you don't want the negative. Square root of 91. I'm just doing a video, I'm on a video at the moment.
Sorry.
Yeah, you're right. So you take the square root of 91, which is 9.53. Okay, cut that off there, put that there, because that's below 5, it stays at 9.5. Job done. Okay, that's the way I would do it if you were using, as I just write here, higher. Okay, so just remove that, take that off, and see how we do it with the foundation way of doing it, as I had the notes earlier. Foundation way. Well, what did I say? You square the numbers. Now, if you want the longest side, you add. Well, the longest side is already given, the hypotenuse, so it's one of the shorter sides, so you subtract. So you do 10 squared, take away 3 squared, which is going to give you 91. And then you just take the square root of that number, and again, if you round that square root to 91, it's 9.53. Because that's below 5, it stays at 9.5 units, whatever that is, to 1 decimal place, and that's the the basics of Pythagoras. It's quite straightforward. So to summarise there, you need a right angle triangle. If you know two sides and require the third, it's always Pythagoras. If it's not, if it doesn't work, if that's not the case being asked, and you're involving angles, or you're not being asked to find one side, if you're given the other two sides, it's right angle. It's going to be trigonometry, which we'll talk about another time. Let's go into a more difficult example. Okay, so let's say, I don't know, this is the side elevation of a shed. Okay, I'll just make this up roughly. The numbers here. So side elevation of a shed. Okay, and let's say we have got, I'll call that 1.1, obviously metres here, to make it realistic, so let's say it's 1.8 metres. So this is 3.2 metres, and on the bottom there we'll call that 2 metres. Now, the question here, we'll use L for length. I could use any letter, X, I'll change my letters. So you want the length of this sloping side of the shed. Now at the moment I've actually got a, the way I've drawn it there, okay, is a trapezium because it's got a pair of parallel sides, it's quadrilateral. Now to use Pythagoras theorem, or trigonometry, depending on which one it is, you need to have a right angle triangle. So what you do, you have to make the triangle appear. So if you do a cut along here, that's definitely right on because that's horizontal, that's vertical. If I now draw the triangle out of the diagram, let's just put that another colour actually, give it a little bit more. So there's your triangle, there's the blue. Now what do we know here? Well, that's the L, what I'm after, the sloping length of the shed. This is definitely 2 metres, But that length, well, that length in between the 3.2 and the 1.8. So what do I need to add on to? That'll be 1.8 there to get that. Well, adding on is the same as subtracting. So if you do 3.2 minus 1.8, that leaves you with 1.4 meters. Check that. If I just go back to my diagram and put that on there, that's 1.4 meters there, from there to there. That's 1.8 meters from there to there. The 3.2 is the height of the whole shed from that side right across. And you now, that plus that makes 3.2. So I can now put that on as 1.4. Now look at your triangle, what we've got a right angle triangle, okay, Pythagoras trig, trigonometry, but you know two sides and require the third, and that's always Pythagoras. So therefore, if you're on the higher tier, you would do L squared equals 1.4 squared plus 2 squared. Okay. Now that, I believe, gives you, I've just done this earlier, 5.96. And you take the square root of 5.96, and that gives, if you round that to one decimal place, you get 2.44. Cut it off to 1 dp unless told otherwise, because that's below. Again, it seems to always come in below 5, doesn't it? The numbers I'm choosing, that's 2.4 meters to 1 dp. Okay, and that's the way you would do it the higher. If you're doing it the foundation way, then what you would do, you go to your triangle, always draw your triangle out to make it easier. No, two sides want the third. Now the longer side is required, so you're going to add and square them. So 2 squared plus 1.4 squared. Okay, just to double check I'm doing that right. .96, yes, I was just worried that I've got the wrong number there. And then obviously, to get the missing length there, you take the positive square or the square root of that, and that gives you what we've got over there, the 2.4 meters rounded to 1 dp. And that's a bit more of a step up, having to come up with the right angle yourself there. Okay. Right, let's look at another more difficult question involving Pythagoras. So I'll take that away. Okay, let's say I want the distance between two coordinates. So I might say 4, 6 to, and I've got written down here, -1, -2. There is a formula which will do this, which we use at A level. Some people might don't want to go into that. You call that x1, y1, x2, y2, and you have a little formula that does it. Just keep it simple though. Well, the simple thing, first of all, is to draw two axes. Origin in the middle, there's your x-axis, there's the positive side to your x-axis, and they're followed by y-axis, y after x. Okay, x as it is a cross, because it looks like a cross, it goes across, followed by y. And you do walk along the corridor and up the stairways to give you your coordinates. So 4, 6 starts at the origin, walk along the corridor to 4, up to 6 is just there, roughly there, 6, put a marker there. Okay, that's in red. Okay, it's just a sketch here I'm doing. And then -1, -2, well, start at the origin, walk along the corridor but the opposite way, -1 somewhere here, and then down the corridor, or down the stairways I should say, there's -2 roughly, and there's my other point there. Join the two up. Okay, it looks like it's going for the origin, doesn't it? It probably isn't going for the origin, it's just a quick sketch. I'm interested in the right angle triangle. Okay, now I want basically the question I should have said there, I want the distance between 4, 6 and -1, -2. And I've plotted the points to make it easy. All I then do is draw a line across here. This is going to form the base of my right angle triangle and down. Now you created your right angle because again, to use Pythagoras, trigonometry, you would need to know to be right angles. Now, how do I do that? Well, if you think about it, what's that distance across here? Well, you've gone 1 that way, because -1's the opposite way, and you've gone 4 that way, so overall, that distance there is 5. Okay, this one here, going vertically, well that's gone 6 up, and that's gone 2 down, so overall that distance there is 8. Okay, so if I take my triangle out of that, draw it here, Once you've got the triangle, you'll know if it's Pythagoras or trigonometry, which obviously it's going to be Pythagoras because that's what I'm doing in this this talk today here. Now that's 8 and 5. I'll call that the length, I'll just call that x again. And I want the length, that is the distance between those 2 points in that grid. Well, again, if you're using a higher way of doing things, you just do the longer side squared, which is this bit, always opposite the right angle squared, equals the other two sides squared, and add it together. That then gives you, from there, have I got that right there? 4, 6, minus 1, minus 2, yes. So that's going to give you 8 squared plus 5 squared, which is going to give us 64 plus 25, which is going to give us 89. Okay, I've got an 89 there. Now I've changed that one. Take the square root of that. I'll just put that into the calculator because I haven't pre-prepared this one. And that gives you 9. Take the square root of that. So that's x squared equals that. Take the square root of that, which is going to give us 4, 5, minus 2, 6, 8. Okay, square root of 89, which comes out again. So I look today on this. 9.43. Again, the number after it's below 5, so it stays there. If that was 5 1, that would go up to 9.5, but it isn't going to go to that. So therefore, it's 9.4 to 1 dp. Done. Okay, and just go over this side here. If I was using the foundation group and I was working from a foundation point of view, okay, keep it more simpler than actually using the full theorem. What I do, well, I want the longer side, so I'm going to add, square the numbers and add them together. So you do 8 squared plus 5 squared, which gives me, as I've done already here, 89. Okay, and then just square root to get the missing side x, call it x, square root of 89, and as I've done there, as you see below there, round that to 1 dp. That. And that's just another problem involving coordinates which does come up in the exam. And then really just to finish, I'll just take this off here. Just a final, well, I'll summarise when I've just finished with this last bit. Put that off there. Okay, there's some useful tricks, especially, this is more of the higher groups now. There's something called Pythagorean triples which you can use. You can spot them in maybe similar triangles. It could be a quick spot to a higher level question. Okay, if you've got the numbers 3, 4, 5, they are work for a Pythagoras. The reason is, if you take a right angle triangle like that, this is more of the higher group now, say that's 3, that's 4, it's not to join, you'll know that 3 squared plus 4 squared equals 5 squared. That's just a test that Pythagoras theorem is working, which means that's going to be a right angle triangle if that rule works. The two shorter sides squared now together. Okay? These are what we call Pythagorean triples and could be useful for more difficult questions to spot key things in similar triangles so you can spot them quicker at doing extensive work. Pythagorean triples. Just put that there. Another one is you could have a 6, 8, 10, and that works again. Key numbers, which is 6, 8, 10. There's a right angle there. 6 squared plus 8 squared equals 10 squared, which works. Just to verify the number above there, 9 plus 16 equals 25, so it works. 36 plus 64 equals 100 works, which means Pythagoras theorem has been stated and it's working to that right angle triangle, which means that's got to be a right angle. And then another one you could have is 5, 12, 13. Okay, the longest side being the hypotenuse, that's 13. Okay, 5, 12, again. 5 squared plus 12 squared equals 13 squared. That's 25 plus 144, which actually equals 169, which is what 13 squared is. 10 squared is 100, so it matches up. And they're useful as the results, and you can scale them up. You can times them by the same number, and it just makes another set of similar triangles where the ratio the numbers stay in the same ratio there. So if you double that, 6, you can actually create this Pythagorean triangle. Double that, double that, double that. Okay. If you times that by 2, or you can times it by what number you want. For example, you could take that top one there and times it by 3, and that will go 3 3s are 9, 3 4s are 12, and 3 pi is 15. That would also form a right angled triangle. 9 squared plus 12 squared is 15 squared. So they could be useful things, but that's the sort of end part, the more difficult bit, if ever used. And a perfect test to show if a triangle is right angled, because the two smaller numbers squared and add together, if they equal the larger number squared, that's another thing you could use to show that it's definitely a right angled triangle. And that's about it. So basically, just to summarise there, Pythagoras' theorem is for a right angled triangle. It's only used if you know two sides of your right angled triangle and you want the third. You use Pythagoras' theorem. It's the square of the longer side equals the square of the two shorter sides added together, and that's how I would use it for the higher groups. For the foundation groups, just to summarise what I've said throughout this, with the foundation groups you would square the numbers and then you've got to decide if you add or subtract. Now if you want the longer side, which is the hypotenuse, if you want the longer side, the hypotenuse, which is opposite the right angle, you'll always add, so square the two numbers and add them, and then square root at the end. If you want one of the shorter sides, you would do otherwise, what I've said earlier, you'll subtract your two numbers, biggest number first so you don't get a minus, square them, subtract them, and then square root at the end, and that will give you your answer, as I've outlined in this session today. Hope that's been useful and you could use that with your GCSE. Thank you very much.